What's up, math students? My name is Michael, and I wanted to do a video talking a little bit about the unit circle. It's something that I kind of didn't fully understand and kind of struggled with when I was in school. I studied mechanical engineering. I got both my bachelor's and my master's in mechanical engineering, and I kind of struggled a little bit with this. And I was helping some friends the other day with some of their math homework, specifically in trig. And I just kind of wanted to go through this a little bit and just kind of talk somewhat about the unit circle itself. And, you know, I've heard a lot of math professors say, hey, well, you just need to memorize this. Like everything that you see here on your screen right now, they're like, hey, you just need to memorize all this. Okay, you need to understand this, you need to know this, you just need to get it in your head and memorize it. And one of the things that while I was helping my friends with their homework, we were working with the unit circle a lot. I started to realize you don't have to memorize the unit circle. Okay, you really don't. If anything, if you have to memorize anything, the only real thing you need to memorize is this first quadrant right here. Okay, if you memorize just this first quadrant, you'll be able to easily get the rest of the quadrants. If you just need to brain dump or something. But I'm going to show you a little bit about it and kind of help you understand it. Now, I hope that by fully understanding the unit circle, it's going to not only help you with questions that revolve around the unit circle, but also other trigonometry questions, and even later on into calculus when you have to do some calculus. There's a lot of things with the unit circle that you'll need. So let's get into it, and I will show you kind of some tricks and things that with the unit circle and help you to understand the unit circle, not just memorize it. So first thing that I want to say and what I want to talk about here, let me grab a red pen here, is I wanted to talk about all these points on the unit circle. This right here is a typical unit circle that you'll see in class if you're taking trig. This is usually what the teacher will put up, is a unit circle that kind of looks like this. And as you notice, it's got lines of angles here, 30, 45, 60 are your kind of your main angles in this first quadrant, and it kind of just has that same kind of style, same kind of feel all throughout. Those three angles, main angles in the middle, and then it has these coordinates along the outside. And so the hardest thing sometimes to do is to remember what those coordinates are supposed to be. And so what I want to do today is I want to kind of go over that and explain a little bit about how you can get those without necessarily having to memorize them. So if you ever do forget and you're on a test and you're like, oh man, I don't know what this is, you can solve it without having to memorize it and without having to know it. So the first thing, I just wanted to show you this real quick because this is probably what you're used to seeing. But what I'd like to do is actually kind of show you what it would look like if you divided this unit circle into twelfths. And by dividing it into twelfths, you'll see that you can get to what these angles are pretty easily. So let me kind of pause real quick here, and I'll come back and I'll show you what it would look like if you divided the unit circle into twelfths. All right. So this is the unit circle, and I just kind of simplified it, took out some of those other points for right now because all I really want to focus on is just the dividing of the unit circle into twelfths. Okay. So imagine if the unit circle was just a big pie, and you could just split it into twelfths. And please excuse the crudeness of this. I drew this kind of by hand here, so it's not drawn to scale. So just kind of keep that in mind. But the thing that I wanted to focus on here is what I've done here with this with these dividing it into twelfths, and I've divided it into pi over 12. Okay. A lot of the problems are that the teacher will have you solve is a lot of times in radians. As you saw on the other unit circle, there were a conversion to degrees as well, which we'll talk about why you don't need to memorize that either. But right now I just want you to focus on, here it is cut into pi over 12 radians, all the way around the circle. So pi over 12, 2 pi over 12, 3 pi over 12, 4 pi over 12, 5 pi over 12, so on and so forth. Okay? And this will help you to get all of those other angles. And what you may be thinking about right now is like, wait a minute, I don't see a pi over 6 or a pi over 4 or a pi over 3 that I'm used to seeing. I don't see it on here on this unit circle right now. So where is that at? Okay, well, if you start simplifying these things, and I kind of already had it cheated there a little bit, but if you start simplifying all of these pi over 12 radians around this circle, you'll find that those angles that you're normally used to are sitting within this circle. So obviously 1 pi over 12 just simplifies to pi over 12. 2 pi over 12 is your pi over 6, okay? So there's your pi over 6. 3 pi over 12 simplifies to pi over 4, okay? And then 4 pi over 12 simplifies to, I'm sorry. Yeah, did I say 4 pi over 4? No, pi over 4. And then 4 pi over 12 simplifies to pi over 3. Okay, and then so on and so forth. You can keep on going. Pi over 6 is pi over 2. This one right here, 8 pi over 12 is, what was that? 4, so that would be 2 pi over 3. Am I doing that right? Yeah, 4, yep. Okay, and then this one would be 3 pi over 4. Okay, and this is 5 pi over 6. So on and so forth. This one right here is pi. We'll stop right there for now, but you can go through all the way around the unit circle, and you would get those same angles that you're used to seeing. Okay, they're right there within all this framework because they just simplify to that. But if you cut it into twelfths, then you don't have to remember, well, it jumps from like pi over 2 to like 2 pi over 3, and then 3 pi over 4, and then, you know, that always kind of messed me up and confused me when I was going through school of, man, I don't remember what's on this side. I could get these sides pretty easily, but then like this side, I was like, man, what is all this supposed to be? I can't remember. Well, if you divide it into twelfths, you can easily just simplify it from there. Okay? And you can figure out what it's supposed to be. The one thing that I will say that may be a little easier for you to kind of memorize and see is, let me just kind of draw a quick little thing out here in green. My ugly hand-drawn circle coordinate system here. One of the things that when you first get to a test and you're like just going to brain dump, well, one things that you can easily pick up really quickly is this is 0, okay? This is 0 degrees, because if I start here and I go all the way around the circle and come back, that's a 360, right? If I start here and go all the way to here and stop here, well, that's only halfway. There's 360 degrees in a full circle, right? If I was to say, hey, do a 360, you'd turn around and like this way and you'd be facing me again. But if I said, hey, do a 180, you'd turn around and you'd be facing the opposite direction, okay? Because that's halfway around. So we know that halfway around the circle, that's going to be 180 degrees. And if you need to memorize something, you're going to probably need some unit conversions a little later on. And you need to know that pi is half of the circle, or in other words, pi is 180 degrees. That's their equivalent. So pi radians equals 180 degrees. Okay, and when you need to convert between radians and degrees, that's the conversion factor that you're going to need to use. Okay, and we'll talk a little bit more about that later, but just kind of focus on this right now of pi equals 180 degrees. So pi is halfway around the circle. So if I was to go a full 360, okay, another half of the circle would be 2 pi. Okay. Actually, those aren't equal. 0 and 2 pi are not equal. It's or 0 or 2 pi because you're going all the way around the circle. Okay? Well, now you're like, okay, well, what about these top ones here? Well, what's halfway between 0 and pi? Maybe pi over 2, right? Half of pi, if I'm going only I'm not going a full pi. I'm only going half pi, right? That would be your pi over 2. And then on this one, you can know that, okay, well now I'm going, so this is pi over 2, this is 2 pi over 2, right? Because I'm doing two half pies basically. So I'm doing 1/2 pi, then I'm doing 2 half pies, or in other words, pi. So now I'm going to go 3 half pi. So this would be 3 pi over 2. And if you look over here, that's what this one is here, 18 pi over 12. That would simplify to 3 pi over 2. Okay? Right? If you take out 6 out of both of those, that's the common factor, 3 pi over 2. Okay? So that's what this one would be. And then your 4 half pies, right? This is, no, I'm sorry, 1 half pi, 2 half pies, 3 half pies, 4 half pies. Right? So this would be 4 pi over 2 or 2 pi. Because I have 4 different sections here. Okay, and I'm only going half pi. Each of these quadrants is only half pi. Okay? So not half the pi, but half pi. Okay? I'm going half of what this pi is. Okay? Not the same pi. All right, there's a pi and then there's a pi. They're not the same thing. Okay? Half of the pi here would only be the pi. Anyway, that's just a dumb joke. Anyway, so that's what each of these quadrants would be. So there, when you start to brain dump, this is what you would throw in here, and you know that if you look at this, right, that's they're perpendicular. So you know that perpendicular is 90 degrees. Probably learned that in either geometry in high school or in your pre-calc algebra class. If they're perpendicular, that means they're 90 degrees to each other. So then you're like, okay, well, what's the degree in this one? Well, if I'm just going another 90 degrees, right, every quadrant is 90 degrees from this point to this point, or that point to that point is an additional 90 degrees. So 180 plus 90 would be 170, right? Yeah, sorry, my math is off today. But 170 is what that would be, or then you'd go all the way back to another, I'm sorry, 270, not 170, my bad. 270, see, I told you my math was off today. And then your 360 right there is another 90, okay? So that's how you could get those outer coordinates, and you would just be able to get that, or those outer angles, pretty easily. Then you would just have to kind of know that, hey, I know I got 3 angles, I remember this from class. What are those angles supposed to be? Well, if you just divide it into 12ths, you'll be able to easily get that. And like I said, I would just do only this one quadrant. So what I would do is I would brain dump this part right here, okay? So then you'd have pi over 12, 2 pi over 12, which is pi over 6, 3 pi over 12, which is pi over 4, sorry, pi over 4, and then you have 4 pi over 12, which is, what I said, pi over 3, and then you have one more, which would be 5 pi over 12, which is just 5 pi over 12. And then, of course, this is 6 pi over 12, or the same thing as pi over 2. And then you're like, well, I gotta get all these, if I need to know exactly what these are, well, again, just divide it into 12ths, okay? You got 7 pi over 12, 8 pi over 12, which is equal to 2 pi over 3, so on and so forth all the way around, right? That's how you would get any of those angles that you might need. But again, so that's how you would get all of those angles around there. So if you wanted to do that real quick, just brain dump and put the pi over 12 everywhere, split your thing into 12ths and do pi over 12, then you would know what that is. And you'd be able to easily do that and easily figure that out. and you wouldn't necessarily have to memorize all of that stuff on that side. Okay, so now we're gonna talk a little bit about, okay, what do we do now? We've got the angles, we understand the angles. What do we do about the rest? Or maybe, hey, I need to know what the degrees is for all of those angles. How do I know what that would be? Well, like I said, you're going to need this conversion factor here of pi equals 180 degrees. So if you say, let's kind of just look at pi over 12, for example. Pi over 12, okay, if you want to know exactly what that degree in angle, that angle would be in degrees, you'd have to put a conversion factor. Okay, and usually in a conversion factor, we always want to take, this is pi radians, okay? You want to take the undesired unit, which in this case is radians, and you want to cancel it out somehow. So if pi radians is at the top, we want to put pi radians down at the bottom here, so that way they cancel out, and then you just put your 180 degrees here. And this doesn't change the result or the answer, right? Because pi equals 180, so 180 degrees divided by pi radians is the same thing as 1. So if I'm multiplying something by 1, I'm not changing the answer. But all we're trying to do is convert pi radians into degrees. Okay? So these pi radians would cancel each other out, and then I'm left with 180 degrees divided by 12, which would then equal, if you were to put that in your calculator, you'd find that equals 15 degrees if I can write properly. But that would equal 15 degrees. So that would be how you could convert between them. So in other words, each of these angles here, this pi over 12 is 15 degrees. So 15, 30, 45, 60, 75, 90, 105, I guess, 120, 135, 40 is 150, 165, and then that would be 180, so on and so forth. Okay, that's how you would figure it out, and you can get your degrees. Okay, so now we're filling out the unit circle. We're slowly getting the unit circle filled out here. Now, the other thing that we need to concern ourselves with, as you've seen in many of these kinds of unit circles, like this one, you have all of these coordinates. Okay, and so now I want to talk about that next. How do we figure out these coordinates? So let's not use our cheat sheet here. Let's kind of come back up here. And let me kind of erase some of this and clear this out, and then I'll come back and explain it some more. Okay, so I've got this all cleaned up here. Let me go back to my red pen here. This angle, we're going to call this is pi over 4, okay? Or 45 degrees, as we saw up there. But now we need to know, okay, what are the coordinates for this angle here, for this point here that intersects this line. Okay, so a lot of times you'll see on the trigonometry problems, they'll say something like, what are the coordinates on the unit circle for a line that intersects the unit circle at such and such an angle? Okay, very confusing wording, but basically all they're trying to say is, hey, what are the coordinates on the unit circle for this angle? Basically, for a line that intersects the unit circle at angle 45, what are the coordinates? Well, the coordinates would be this point right here. And if you look at this is the y-axis and the x-axis. Basically, you have an x and y coordinate, okay? And that's what we're trying to figure out here. So let me kind of back up a little bit and just kind of go to where this is the 0, this is pi over 2, or 90 degrees. This is your pi, or your 180 degrees. Ooh, my goodness. And this is your, 3 pi over 2, yeah. See, I'm already messing up. 3 pi over 2, which is also equal to 270. And then, of course, back to this one is 2 pi, or could be 360 degrees. Okay, or 0, right? This is the infinite circle here. Okay. So the one thing that I want you guys to realize about a unit circle is a unit circle means that it has a radius of 1, okay? 1 unit. It's literally the unit circle. It's 1 unit, 1 mile, 1 meter, 1 foot, 1 yard, 1 inch, whatever. It's 1. It's a unit of 1. So that's what it means by it's called the unit circle. And the definition of a circle is that it has a continuous radius, meaning that at any point along this circle, the radius is going to be the same. So if we're in a unit circle, that means the radius is going to be 1. Okay? It's always going to have a radius of 1. At any point along the perimeter of this circle right here, no matter what point I'm on, I'm always going to be 1 unit from the center of the circle. Okay? That's what that means to be a unit circle. Is that you're always going to have a radius of 1, no matter if I draw a line here, if I draw a line there, if I draw a line over this way, if I draw it that way, if I draw it over this way, it's all going to be a radius of 1. Okay? So therefore, just looking at the tips of the unit circle, we can say that out here this is 1, this is 1, this is 1, and this is 1. Okay? At any point along these edges, it's always 1. Okay, so going from here to all the way over here, that's 1 unit. Okay, and it's going to be 1. Oh, what the heck happened there? Not really sure what happened there, but it's always going to be 1. 1 is going to be your coordinate. Now, again, this is the x-axis, and this is the y-axis. So if I'm over here at 0, okay, my coordinates would be what? My coordinates would, for this point, would have to be, I moved over 1 in x, but I haven't gone anywhere in y, right? My y, I'm still on the x-axis, so therefore my y would be 0, okay? Same thing for this one. If I'm here, that means I've gone up 1 in y, but I'm on the y-axis, so I haven't moved anywhere in x, so therefore my x would be 0. Okay, same thing over here. I am over in 1 on the x-axis, so therefore my x-coordinate would be 1, and my y-coordinate, I'm not moving anywhere on the y-axis, so my y-coordinate would be 0. Now, the one thing that we have to realize that on this side, okay, this is the y-axis, on this side of the y-axis in these two quadrants, my x-coordinates are always going to be negative because I am on the negative side of the x-axis, okay? Or on the negative side of x. All of these x's on this side are all negative. All the x's on this side are all positive. So in these two coordinates, I am always going to have a negative x-coordinate, okay? So therefore, I'm on this side of the x quadrant, therefore I'm going to have a negative x coordinate of 1 and then a 0 of y. Same thing for down here. If I'm in these two quadrants here, okay, I'm going to erase these so I don't confuse anybody here. But if I'm in these two quadrants here, I'm on the positive side of the y-axis. I'm on the positive side of y. Okay, so all of my coordinates all my y coordinates in these two quadrants will always be positive. All of my y coordinates in these two quadrants will always be negative because I'm now on the negative side of y. So in this case, right here, I'm not moving anywhere in x, so my x coordinate would be 0, and my y coordinate would be -1. Okay, because I'm on the negative side of the y. Of y. So that's how you could get those outer bands, knowing that hey, it's a radius of 1 if I'm all the way on these edges. At the x and y coordinates, this is what it would be. 1, 0, 0, 1, negative 1, 0, 0, negative 1. Okay? And again, if I'm in these two quadrants, I'm negative x. If I'm in these two quadrants, I'm positive x. If I'm in these two quadrants, I'm positive y. And if I'm in these two quadrants, I'm negative y. Always and forever. Okay? Always and forever. So now you're saying, okay, well, those are easy. Okay, I got those. Well, again, we still have to realize that even if we're on a coordinate like this, way out here between the x and y coordinate systems, we have to we still know that no matter where we're at along this this perimeter of the circle, it's always going to be a radius of 1. And if you look at this and you say, okay, well, I got a radius of 1, but that doesn't tell me what this point is, so what do I do now? Well, this kind of goes back to your kind of geometry days, or maybe even pre-calc algebra. I can't even remember where you really learned this at, but you know about triangles, right? So get this. If I take a line and I draw it straight down here, I'm going to try to draw it as straight as I can. That actually wasn't too bad. Not great, but not too bad. I now have formed a triangle, a right triangle to be precise, okay? And so now I can use all of my tools of a triangle to be able to figure out what this coordinate is. And so I'm sure maybe you guys have seen the whole Pythagorean theorem, which is a squared plus b squared equals c squared, right? And so you say, oh, well, I can use my a, my b, and my c, okay, to figure out, I can solve for one of them if I have the other two. Okay, well, unfortunately, the only one that we have is c, which is the same thing as the radius of the circle, which is 1, which this is also called our hypotenuse. Okay, so we have the hypotenuse, and we have the angle, but we don't have anything else. We don't have our x, or I'm sorry, we don't have our x and we don't have our y. So I'm going to say a is also equal to x and b is also equal to y. So really, this doesn't help us because we don't have enough information to solve for that. So that's not going to help us. So now what do we do? Well, there's other tools from a triangle that we can use. And I don't know if you guys have ever seen this one, but there's an acronym called SOHCAHTOA. And let me capitalize that A. SOHCAHTOA. Okay? So I don't know if you guys have ever seen this before, but SOHCAHTOA is an acronym for sine is opposite over hypotenuse. And I don't think I'm spelling that right, but let's just pretend like that's how you spell hypotenuse. Okay? And then cosine, this is the ka part of SOHCAHTOA, cosine is adjacent over hypotenuse. Okay? And then tangent is opposite over, oh man, I cannot write, adjacent. Sure, let's pretend like that's how you write words. Okay, so what I mean, and let's talk about what I mean by this, okay? And again, maybe most of you know this, but in case some of you don't, this is why I'm kind of going through it. But what I mean by opposite is, okay, here's my angle right here, okay? This is my angle theta. Or as some of my professors used to say, theta. So this is theta right here. Opposite of this angle is the side B, okay? It's on the opposite side, right? It's facing it, it's looking at it, it's opposite to this side right here. So in other words, my sine of my angle, okay, this is sine of my angle, you write this over here, up here, sine of theta is going to be B as my side B, or Y, we'll write it both ways, but I'm going to say B over C. Or in other words, y over r, which is the radius, right? R is radius. Okay, so that would be what sine would be. Okay, cosine is the adjacent side. Okay, is the side that's next to theta. Okay, that is the side that's alongside of it. So cosine of the angle would be A over C, okay, because this is adjacent over hypotenuse, or in other words, what we're trying to look at, this would be x over r, okay, which is our radius over our x coordinate, okay? So that's what that would be. Now, you could also use another one that's tangent of theta is going to be equal to the opposite, which is B, over the adjacent, which is A, or in other words, y over x. So that right there are three extra equations that we can use to solve for this coordinate system right here. And figure out what our x and y is, okay? And the thing that I want to kind of point out here is when you look at this, you say, let's take this equation, for example, cosine is equal to x over r. Well, r is just equal to 1, so anything divided by 1 is just itself. So therefore, this can be simplified to cosine of theta equals x. And that's the thing that I want you to realize from this, is that my x coordinate is also the cosine of my angle, okay? And my y coordinate, we can do the same thing with sine theta is y over r, which r equals 1, so therefore that can be reduced to sine of theta equals y. So my y coordinate is sine theta, okay, or theta. Those are what your coordinates would be. So therefore, if I took this coordinate right here, this pi over 4, okay, my pi over 4 would be, for my x coordinate, it would be cosine of pi over 4, or cosine of cosine of 45 degrees, whichever, one you're using. It doesn't matter, you're going to get the same answer so long as your calculator is in, whatever your calculator is in, that's the units that you need to use. So if it's in radians, you need to use the pi over 4. If it's in degrees, you need to use 45 degrees. That would then give you what this would be. And if you were to type that into the calculator, your cosine of theta would end up being a number that looks like this, 71 or 70. I'm going to head it over here real quick. Let me see if I can go back. Yes, 7, as you can see here, 0.7071. That's what we'll write. 7071, something like that, okay? Let me just double check that. Yeah, okay. So that's what it would be. That's what your angle would be if you were to do cosine of pi over 4 or 45 degrees, you would get this number. Now you're looking at me like, okay, well, what the heck is that? That's not a number. Like, we don't know what that is. How do we convert that? And this is where you might have to. This would be the one of the few things that you would have to memorize on the unit circle, because they're like, your teacher wants it in absolute form. And one of the things, like if we scroll back down here, one of the things that you'll remember from the unit circle is these are the three numbers you got to look at. You got 1/2, you've got square root of 3 over 2, and you've got square root of 2 over 2. Those are the only three numbers that you really need to memorize, okay? Is those three numbers right there, okay? Because whatever you do, it's going to be one of those three numbers for any of these main coordinates here, okay? For these main ones that the teacher wants you to memorize. So how do we know which one this one is? Well, you can easily guess and check, right? You can just simply type it into your calculator square root of 2 over 2, what does that equal? Oh, well, guess what? It equals that, okay? And square root of 3, I'll give you this, square root of 3 over 2 is going to be equal to 0.866 something. Okay, but that's what square root of 3 over 2 is going to equal if you were to type that into your calculator. And then, of course, 1/2 would equal 0.5. So if you get this number with pi over 4, then you know, okay, oh, my x-coordinate is going to be square root of 2 over 2. Well, then now you got to do the same thing for sine of pi over 4. And if you were to do sine of pi over 4, you would get the same square root of 2 over 2. Okay? And that's how you can figure out easily and very simply what the coordinates are. Now, the only other real coordinate that you really would then need to worry about is this 30 degree one, or pi over 6. Okay? So now you gotta figure out what those coordinates are. Well, the same thing applies. Cosine of the angle, sine of the angle. Okay, cosine is your x, sine is your y. So if you were to do cosine of pi over 6, you would find that you would end up with 0.5 on your calculator, and you would get 1/2. And let me just just to verify that, let's go pi divided by 6. And I know you can't really see what I'm doing, but I'm just typing in pi divided by 6, and then I do cosine, and I screwed that up. Sorry, I messed that up. This is supposed to be square root of 3 over 2. Sorry, that was my bad. Sine of pi over 6 is 1/2. Sorry about that. So let me redo that. That's why it's good to check, right? Because even I make a mistake when doing that. But what you would see if you were to type in cosine of pi over 6, what you would end up getting is 0.866, which is this up here. So you would know that, okay, the 0.866 is square root of 3 over 2. My y coordinate, again, you could type that in, and you could do, just because I screwed up there, let's go ahead and just verify it. Pi over 6, pi divided by 6. The sine of that is going to be 1/2. Okay? So again, just typing simply into your calculator, that's what it would get. If you're not allowed to use a calculator, because I know some professors maybe say like, oh, you have to do this exactly and give me the exact answer, but you're not allowed to use a calculator. I don't understand why they always do that. It doesn't make any sense. Why the heck would you not use a calculator if you're doing math? Okay, I'm an engineer. I use calculators all the time in real life. I've never not used the calculator. I don't know why you would not use it to verify your results, make sure that you don't make a mental math mistake or whatever, but that's fine. If they say that you can't do that, then unfortunately these coordinates are the ones that you would have to memorize. Just these. Okay, and I'm going to explain to you why just these. Okay? So now I have these coordinates. I'm going to go ahead and switch over to blue now in a different color. But I have these coordinates now, okay, for pi over 6 and pi over 4. And let's just say, again, I had to memorize them, that pi over 4 is square root of 2 over 2, square root of 2 over 2, and pi over 6 is square root of 3 over 2 and 1/2. Okay? What's interesting is the other major angle that you have in this quadrant is pi over 3. Well, pi over 3 is just going to be the opposite in x and y of what pi over 6 is. So in this case, this would be 1/2 square root of 3 over 2. Okay? So if you just remember these two, then the only other thing that you would have to remember is that pi over 3 is the opposite of pi over 6. And therefore, it would be 1/2 and square root of 3 over 2. Maybe it might just be better for you to memorize that as well, and yes, you would just have to remember those 3 angles and memorize those 3 angles. But for me, that's kind of how my brain works. I'm just like, okay, I remember these two, and I can easily brain dump these two on a test real quick, and then I just would know, oh yeah, pi over 3 is the opposite of pi over 6 as far as coordinates go. And again, we can check that. Let's do pi over 3. Cosine of that angle is 1/2. and then pi over 3 of the sine of pi over 3 is 0.866, which is square root of 3 over 2. So that's how you would, that's how you could easily get to those. And those three right there, those are the main angles. Those are the ones that you really just need to memorize. If you're going to memorize anything on here, you should only have to memorize those. And the reason why you should only have to memorize those is because an angle out this way, okay, let's say this is the same angle as this pi over 3, but on the opposite side of the y-axis, okay? So on this, you look at this and you say, okay, you got the y-axis here, and this way is pi over 3. This way, okay, would be what? Well, I can't think of what that would be. It's supposed to be 2 pi over 3, right? This one would be 2 pi over 3. But oh man, I can't remember that that's supposed to be 2 pi over 3. Well, guess what? If I go back to my 12ths, right? If I'm cutting it in 12ths, and I say, okay, this right here is going to be 6 pi over 12. This right here is going to be, what is it, 12? 4 pi over 12, right? So now I'm skipping 2 pi from going from here to get to 6 pi. So my next one, I got to go 2 more. That would be 8 pi over 12, which reduces to 2 pi over 3. Okay? And again, that's what I'm talking about, splitting this into 12ths. Okay? And even if you needed to, like, oh, well, I don't remember that, so let's go, oh, this is 5 pi over 12. Okay, so this is 6 pi over 12. Then this one would be 7 pi over 12. And that means this is 8 pi over 12. Oh, that's the one that I need. 8 pi over 12, which is 2 pi over 3. Boom. Well, what's interesting about this is that these right here would have the same coordinates as its, I want to be careful how I use the word here because it's not really, I don't know if it's supplementary angle. It's not supplementary angle, but it's the same amount of angle away from the y-axis, okay? So this one is basically, again, this 4 pi over 12, 6 pi over 12. That's 2 pi over 12 difference between this angle and the y-axis. So that means going this way, this angle is also, again, it's 8 pi over 12 versus 6 pi over 12. That's 2 pi over 12 difference in angle, okay? So they're going to have the same coordinates because it's the same distance away from the y-axis, okay? So these two, let me go ahead and erase these extra ones that I drew here. But these two angles right here will have the same coordinates as each other. However, again, as I said before, all x coordinates on this side of the y-axis would be negative, and all of the x's on this side of the y-axis would be positive. Okay, so in this case, the coordinate for 8 pi over 12, or 2 pi over 3, would be negative 1/2 square root of 3 over 2. And you know that this is positive on the y side of things because I'm on the positive side of y, or on the positive side of the x-axis. Okay? Right? I'm above the x-axis, so therefore I am positive y. Okay? Versus when I get down here and I get that same angle over this way, okay, which this angle, right, I know this one to be, this is 18 pi over 12, so I go 2 pi less than that is going to be 16 pi over 12, so that's going to be 4 pi over 3. And let me just double check to make sure that I'm correct there. Yes, you're 4 pi over 3 right here. Okay? And again, as you can see here, these coordinates for this one is going to be the exact same as this one and this one, except now we're on the bottom side of the
y-axis. So we're on the negative side of y, we're on the negative side of x, so therefore both my coordinates in this one would be negative. Okay? So hopefully that makes sense. What I'm saying there is like, hey, I'm equally the same amount away from the y-axis, just on a different side of the unit circle. So therefore my coordinates will be very similar, except they will be negative or positive. Okay? So now let me switch back to green, or let me do red first. Let's do our 45 degrees, an equivalent angle here to this one. Okay, so that's 8 pi over 12. This is going to be 9 pi, something like that, over 12, or 3 pi over 4. Okay, so this is 3 pi over 4, right? 3 pi over 4. Let me try to see if I can write that 9 a little better. 3 pi over 4, okay? And then, so what would those coordinates be? Well, I'm on the negative, they would have a similar coordinate as this one here, okay? So I'm on the negative side of x, so I'm going to have a negative 2 square root of 2 over 2. I'm on the positive side of y, so I'm going to have a square root of 2 over 2. And to verify that, 3 pi over 4, let's go down here. 3 pi over 4, look at that. Minus square root of 2 over 2, square root of 2 over 2. Those are my coordinates for that one. Don't know what that is. But so hopefully, I hope you guys understand that. I hope you guys are kind of getting this, what I'm saying here. And, this can continue onward. We can even go now to my green one here and say, what is this pi over 6, okay, right here? Well, guess what this one's going to be? Well, this one is going to be, I can tell you right now it's going to be, what did I say? Oh, yeah, 10 pi, here we go, 10 pi over 12. So what is that going to be? That's going to be 5 pi over 6, okay? And that one's going to have the same coordinates as this pi over 6, except it's going to be negative x, square root of 3 over 2, and 1/2. Okay? Positive y because I'm on the positive side of y. Okay? So that's what those coordinates would be for 5 pi over 6. Come down to our cheat sheet here. Look at that. 5 pi over 6 minus square root of 3 over 2, 1/2. Okay? Just like we've been saying. Now what's interesting is if you look at this, you can also kind of quickly get a few things here by dividing things by the other angles as well. So I don't know if I'm really explaining that. That doesn't really make a whole lot of sense. But let's say, for example, let me use this pi over 4. In fact, let me just kind of scroll down a little bit here and just redraw another circle real quick. That is a terrible circle, but we'll go ahead and pretend like that's a really nice circle. And let me just use that same red pen to focus on my pi over 4. Okay? So if I look at this, I can even divide this into just these angles. Like I've been talking to you about dividing it into 12ths, but what if I just divide it, if I really understand it, then I could just divide it into my angles themselves, right? By this, in this case, this is by pi over 4. So in other words, this would still be 0. This is 1 pi over 4. This is 2 pi over 4, or pi over 2. This is 3 pi over 4. This is 4 pi over 4, or pi. This one is 5 pi over 4. This one is 6 pi over 4, or 3 pi over 2. 3 pi over 2. And let's see if I can draw all 3. And then this one would be another fourth, which is 7 pi over 4. And then your 8 pi over 4, or 2 pi. Okay?
So you see what I'm saying? So now I can divide that out. Okay, well now let's look at this. Let's look at our ones for pi over 6. Actually, let's do pi over 3 first. Let's do pi over 3, which is blue. Okay, so now we're looking at this one. We're going to divide up into. Hang on. See if I can draw it a little bit better. Going to divide up now into thirds here, like this. Okay, so this one we know is pi over 3. Okay, well this one is 2 pi over 3. Well this one, hold on, let's do that. 0. So 0, if I go all the way this way, this is pi over 3. Then I'd have to go that same amount of distance, okay, to here. And again, this is not drawn to scale, but they should be, you know, a similar. If I was to measure this arc length and this arc length, they would be the same. Okay, they would be an equal arc length. Okay, same amount of distance traveled. That would give us to the 2 pi over 3. Then if I measure to here, this would get me the same arc length to 3 pi over 3, which is also equal to pi. Then this same arc length, right, over to here, okay, and again, not drawn to scale, so that's kind of why it looks really kind of just crappy, and they don't look the same distances, you know, around here, but they're again, just kind of imagine, you know, again, imagine if this was drawn to scale, this would be the same distance, same arc lengths around these points. But anyway, so this now would be 4 pi over 3, and then this one would be 5 pi over 3, and this one would be 6 pi over 3, or pi over 2. Okay, so that's how you could get to those maybe a little bit quicker if you just needed to know what these angles are. Again, same thing. If we wanted to, we could do with the 6, 1/6 pi right here. Ooh, there you go. This one would be like this, like this. This would be pi over 6, 2 pi over 6, or pi over 3. This one would then be 3 pi over 6, or pi over 2. Same thing here, same thing here. And again, I cannot draw these to scale. These are terrible. Okay. And again, same arc length distance between these right here. Okay. It's an angle of the pi over 6. So pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, which is also equal to 2 pi over 3. Then you have 5 pi over 6. Then you have another going that way and another going that way. And then again, same arc length. This one would be, to here, sorry. This would be 6 pi over 6, which is equal to pi. And then this one right here would be 7 pi over 6, so on and so forth. 8 pi over 6, which is also equal to 4 pi over 3. Okay, and then this is right here, 9 pi over 6. It's also equal to 3 pi over 2. And then you have these right here. This one would be 10 pi over 6, which is also equal to 5 pi over 3. And then you have 11 pi over 6. 5 pi over 6. And then you have your 12 pi, 12 pi over 6, which is also equal to 2 pi, or 0 at this point.
Okay, hopefully that wasn't too confusing, but because again, it's not drawn to scale, so it's kind of harder to see it that way. I think it's easier when you do it like this, when you see it in your quarters, you know, in your fourths, pi over 4. So maybe I wouldn't even worry about doing this on a test or something like that if I was trying to brain dump, but I would do it, and that was supposed to be green. But anyway, I would do it like this, maybe. You know, I'd be like, okay, well, I've got my pi over 4, and then I know that between pi over 4 and the x-axis is pi over 6, and that's going to be the same thing here. And then I've got, you know, I've got another one, another pi over 6 that way, and then I've got another pi over 6 that way. Okay, right, I'm coming off the x-axis in all 4 quadrants by pi over 6. And then for my blues, these are my pi over 3s. I'm coming off the y-axis for pi over 3. And those are my main angles right there. So I can say that this is pi over 3. And then I could say, again, then I could go back through this, I guess, if you really needed to. If you're like, oh crap, I need to figure that out. This would be 2 pi over 3. This one would be, I'm not looking over there because I want to try to get it here. This would be 3 pi over 3. This would be 4 pi over 3. Okay. Then I go over here to 5 pi over 3. And then this would be 6 pi over 3. Okay. So you can do it that way. And then your 6's, right? Again, 6 pi over 6, 2 pi over 6, 4 pi over 3, another 6th, another 6th, and then another 6th over here. So this would be 1, 2, 3, 4, 5, 5 pi over 6, and then 6, 7 pi over 6, and then 8, 9, 10, and 11 pi over 6. And so that could get it to you pretty quickly. And if you come up over here, that's exactly what they are. Okay. So hopefully that makes sense. Hopefully that makes sense of how to get that pretty quickly. Those are all your angles that you would need. And again, we've talked about these coordinates of how to get those. Like I said, let's just say, well, I've already memorized these, so I'm just going to say this is definitely square root of 2, square root of 2 over 2, and then this one is square root of 3 over 2, 1/2, and then I know that this is 1/2 square root of 3 over 2 over here. Actually, let me change them to the colors so that all the colors line up. Probably wouldn't be a bad idea to do that. So this one would be 1/2 square root of 3 over 2, and then this one would be square root of 2 over 2. Boom. So then now I know it's like, okay, well in this one I'm on the negative side of the x, so it should have this exact same coordinate right here, but it's going to be negative square root of 2 over 2 square root of 2 over 2 because I'm on the negative side of the x-axis. Let's redo that so it's a little clearer. But I'm on the positive side of y, okay? Negative side of x, positive side of y. So that's what that would be. Then I come down here to this guy, and it's like, okay, it's going to have the same exact coordinate, except now I'm going to be on the negative side of x and the negative side of y. So then I'm going to do negative square root of 2, negative square root of 2 over 2 for that one. Then on this one, I'm on the positive side of x, but I'm on the negative side of y. So I'm still going to have the same coordinates, but now I'm on the negative side of y, but I'm on the positive side of x, okay? And those would be all those coordinates. Then you say, okay, well now I got to get all the 3's. Well, this is my coordinates for the 3's. Over here, I am negative 1/2 because I'm on the negative side of x, square root of 3 because I'm on the positive side of y. Then I come down to this one and I say, okay, I'm on the negative side of x still, so I'm still going to be negative 1/2, but now I'm going to be negative square root of 3 over 2 because I'm on the negative side of y. And over here on this one, I'm now on the positive side of x, but I'm still on the negative side of y.
Okay, so that's why I say these are the only three. Ooh, darn it! Why is it doing that? Stop it! Stop it! What are we doing? Something's like writing crap. Like, don't be writing crap until I tell you to write crap. What are we doing? I don't know what we're doing, but anyway. Right? These are the only three that you really need to. Well, I don't even know how to freaking write anything because it was all messing me up here. These are the only three coordinates that you would really need to memorize, okay, if you had to memorize them. But again, if you can use a calculator, you can easily check yourself to make sure that you've got the right ones by doing this whole process here with the triangle and understanding. Really, you don't even need to do all the whole triangle and stuff. All you need to know is that the x-coordinate is cosine of the angle, and the y-coordinate is the sine of the angle. This was all just to derive that, to show you that the x is the cosine, the y is the sine. Okay? So that's all you would have to do, and you could get your coordinates that way. But if you can't use a calculator, then unfortunately you would have to memorize these. But again, really the only two you would really need to memorize is pi over 4 is square root of 2 over 2, square root of 2 over 2, and then pi over 6 is square root of 3 over 2, 1/2, and then the pi over 3 is just the opposite, okay? It's the opposite of what the pi over 6 is, okay? Does that make sense? Hopefully it does. But that's what I would, if you had to memorize anything, those would be the only parts that I would memorize. Everything else, you can just get it by visualization and understanding all you know, that each of these points, okay, are the same thing. Okay, this is going to be the same coordinates. And now we can say, well, I haven't even checked it yet, but we can go ahead and check this and say, okay, what's my 2 pi over 3? Is it minus 1/2 square root of 3? Oh, look at that. 2 pi over 3 minus 1/2 square root of 3 over 2. Okay? Well, now I want to check, let's go over here. This one should be what? Well, I'm on the positive side of x. Oops, I'm not green. Let's see, I'm on the positive side of x, so this one should be square root of 3 over 2, and then on the negative side of y, so I should be negative 1/2. So according to the unit circle, I should be 11 pi over 6. Coordinates are square root of 3 over 2, negative 1/2, and look at that, 11 pi over 6, square root of 3 over 2, minus 1/2. Okay, so that is the unit circle. And like I said, this is kind of a long video, I know, but if you really understand about just dividing the unit circle into 12ths, it can make it very easy for you to get all of these things. And again, remembering that pi over 12 is every 15 degrees, then you can easily get what degree that you need, what it is and what you need to be in. Or if you don't necessarily remember that, just always know that pi is equal to 180. You can convert any of these into degrees using a conversion factor of 180 degrees over pi multiplied by whatever your angle is. So let's say in this case it's 2 pi over 3 is your angle. Well, I need to convert that into degrees. Okay, the pi radians would cancel out, and you're left with 2 times 180 divided by 3, which is going to be 360 divided by 3, which then would equal 120. Bam. Now if we go down to 2 pi over 3 on our unit circle cheat sheet, look at that. 2 pi over 3 is 120. Okay? So again, this whole thing about memorizing the unit circle, you really don't have to. I would say again, the only things that you would have to memorize is maybe this right here. But even at that, you don't necessarily have to memorize that. Okay? But I hope that this helps. I hope that this is clear. If it's not, maybe put down in the comments or below your questions. But I hope it's clear. I hope it's understandable. Maybe it's just the way my brain works, but for me, this is just kind of was an epiphany as I was helping my friends do their trig homework, And this really helps, I think, to understand the unit circle. And if you really understand all of this stuff, it's going to make the problems that you're working on a whole lot easier. So again, like when they ask for, okay, hey, tell me the coordinates on the unit circle for a line that intersects the unit circle at 120 degrees. Tell me what the exact coordinates are for a line that intersects the unit circle at 120 degrees. That's such weird wording and confusing sometimes, but now you kind of understand, like, oh, what they're asking for is I need to go on my unit circle 120 degrees, and I need to find out what those coordinates are. But now, what if they're like, okay, well, this is the unit circle, and this is why I'm saying you have to understand the unit circle, because what if they ask you for an angle of 110? All right, find the coordinates, exact coordinates for a line that intersects the unit circle at 110 degrees. Well, how are you going to solve that? Well, crap, I don't know what 110 degrees, like, I don't know what those coordinates are. So how am I going to solve that? Again, you already know cosine of theta is your x coordinate, and sine of theta is your y coordinate. Okay? So now you know I can just easily put in cosine of 110 is my x coordinate, and sine of 110 is my y coordinate, and I would get that, and you'd be able to do that and to figure that out. So hopefully that helps. Or and again, maybe if they say, well, now give me that angle in radians is the next part of the problem. Well, okay, no problem. I can just do 110 degrees, right, times my conversion factor, which in this case, my undesirable units is degrees. So I'm going to put the degrees on the bottom to cancel this out, because imagine this is 110 over 1 or something. It's on the top, so I'm needing to put my degrees on the bottom so that way they cancel each other out, and then I just put my pi on top. So what you're left with is 110 pi divided by 180, and that will give it to you what it would be in radians, which I can quickly do that for you. 110 times pi divided by 180. Nope, that's not 180. 180 is going to be equal to 1.9 19862 blah 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 radians. Okay, so that's what it would be in radians. Okay. So anyway, that's just how you could use the unit circle to help solve some of these problems that you'll come across and that you'll find. The other thing I wanted to quickly kind of share as well is one problem that I saw my one friend on his homework was what was it? It was something about, I don't know, I kind of can't remember. It was something about, like, the radius, like find the I guess basically find what distance a ladder needs to be set away from the wall on a unit circle or something in order to lean at this angle, or like how far away would you have to put the base of the ladder or something like that. I can't even really remember, but we know, again, on the unit circle the radius is 1. Okay, at a distance, there's something like that. It was like, how did it word it? It was like find the distance at which the ladder would have to be away from the wall to be 1 unit at this angle or something like that. Anyway, but you would just be able to do this. You'd be able to use the unit circle like in this fashion, just again drawing like the triangles like we did earlier when we were deriving that what x and y is. Well, we need to know what this x coordinate is, so we need to say, okay, how far of a distance from the wall does the base of the ladder need to be? Okay, well, I know that that's my x coordinate. Okay, my x length right here. Where my x coordinate is my x length. Okay, and here's my y, and we're saying that the radius is 1. Okay, well, how do I solve for that? Well, it's gave me the angle. Let's say if it gave me the angle of 45 degrees that it wants it to lean at. Well, now I can solve for my x again simply by doing cosine of theta, right? Cosine of 45 degrees would give me what my x value would need to be, which we know at 45 degrees would be square root of 2 over 2. Okay? Hopefully all that makes sense. But again, let me know if you have any questions. Like I said, this is something that can really help in trig